Hello guys, welcome to our Curator channel. This is our fourth lecture on signals and system in English. Today we are going to discuss about few basic signal operations and how to represent a continuous time signal and a discrete time signal. First let us see how to represent continuous time signal and discrete time signal, then followed by it we can discuss about few basic signal operations. As I said before, any continuous time signal, let x of t be a continuous time signal, can be represented as a function of time, like t or x of t equal to t square plus 1, or x of t equal to t for t less than 0, t plus 1 for t greater than or equal to 0. This way, any of the way we can represent it in any way, like this, as a function of time. At the same time, we can plot a graph as usual, like in x-axis we can mark time t as a variable, in y-axis x of t as a function. This x varies with respect to time, so we representing this as x of t. Otherwise this is just x. Here it is 0. Time will keep on reduce like this, minus 1, minus 2, minus 3 until minus infinity. Here it will increase like 1, 2, 3 up to infinity. The same way for x. This is how we plot a continuous time signal. A discrete time signal will be denoted as x of n. In previous lecture we discussed why we should represent this as n. It is just a count of discretized time. So this can be represented as function as well, like n square, or x of n equal to 2n plus 1, or x of n equal to n by 2. Anyway, you can represent this as a function of n. Also we can represent x of n as a set of values, like 1, 3, 4, or x of n equal to 5, 1, 2, 0, 3. Like this we can represent x of n as set of values. Here if we didn't denoted any time origin in the set of values, it means the first element is in n equal to 0 if they didn't denoted anything about time index. Otherwise, if they mention x of n is equal to 1, minus 1, 2, 0, 1, like this, for example, if they mention arrow mark here, it means n index will be represented like this, will be marked like this. N equal to 0 here it takes n equal to 1, here n takes the value of 2, here n equal to minus 1, here n equal to minus 2. This way we can represent x of n as set of values. This both can be plotted as graph. For example, let me plot x of n equal to n plus 1 now. So the same way n will be marked in x-axis, and x of n here, this is 0. When n is equal to 0, x of n will be x of 0, so n will be replaced with 0 here, so x of 0 equal to 1. So x of 0 is 1 for n equal to 0. When we consider n is equal to 1, then x of 1 is equal to 1 plus 1, 2. Here n is equal to 1. Same way, this is 2, this is 3, this is 4, it will be plotted like this. As we plot continuous time signal, we cannot plot this discrete time signal continuously. It will be like a stem plot like this. It won't have a continuous value with respect to n. At that specific instant, like n equal to 0, n equal to 1, n equal to 3, n equal to 2, 3, it will have value. In between 2 and 3, in between two successive values of n, there won't be any data, there won't be any values for x of n. It will be like a stem plot like this, clear stem plot. So this is how we can plot x of n, which is represented as a function. Now let us see how to plot a set of values of x of n. If x of n is equal to some set of value like 2, 3, 2, 1, 0, minus 1. Here n index is, origin of n index is here. So we can plot this signal like this. Here we can mark this as n. Here it is 0. Here it is x of n. So when n equal to 0, we can plot value of x as 3. Let it be 1, 2, and this is 3. When n equal to 0, x of n is 3. We can plot this as a stem. And this is n equal to minus 1. For n equal to minus 1, we have value of x of n as 2. So it will be 2 here for minus 1. For plus 1, n equal to plus 1, we have x of n equal to 2 again. Like this. This is plus 1. For n equal to 2 here, we have x of n is equal to 1. For n equal to 3, we have x of n equal to 0. For n equal to 4, we have x of n equal to minus 1. This is minus 1. This is 4. So this is how we can plot a discrete time signal graphically. Now let us discuss about basic signal operations. Few basic signal operations. First operation, there are totally four operations we see here. One is amplitude scaling, another one is time scaling, and time reversal, and time shifting. There are 4 operations involved here. These are the 4 basic operations in our subject. Let us consider amplitude scaling now. Amplitude scaling is like multiplying a scalar value with our x of t signal. Let us consider a signal x of t equal to t. Here if we multiply a scalar value and now let another signal x1 of t be x1 of t equal to a into x of t, then this x1 of t is amplitude scaled version of this x of t. Here we scaled this x of t with amplitude a. So this x1 of t is amplitude scaled version of x of t. This a can be any integer like 0, 1 by 2, minus 1 by 2, 5, minus 5, 2, minus 2, 3, minus 6, anything. It can be anything. If we scale any signal like this, how it will affect that signal? Let us see now. Let us take a unit step signal as example. U of t is equal to 1 for t greater than or equal to 0, 0 otherwise. Now let us consider its graph too. We already know how to plot unit step signal. This is u of t. It will be 1 throughout for all values of t. when t greater than or equal to 0. So it will be plotted like this. Now let us plot a graph for 2 into u of t. Now if I multiply 2 on both sides of this, what we will get? 2 into u of t is equal to, I can multiply 2 here too, so it will become 2 for t greater than or equal to 0 and 0 otherwise. So the value will become 2. So it will be like this. This is 1, this is 2. For all values of t greater than or equal to 0, our new signal 2 into u of t will have value of 2 for all values of t when t greater than or equal to 0. Another example with the same unit step signal. If I want to mark minus u of t, that means I multiplied this signal with minus 1, what I will get? Now the same way I will multiply minus 1 both sides of this unit step signals mathematical model. If I do so, I will get minus sign this side and this 1 will become minus 1. So minus u of t will have minus 1 for all values of t greater than or equal to 0. So this is amplitude scaling. You can scale your amplitude with the negative values, with positive values, with decimal values, float values, anything, whatever you want. If your scaling value is in between 0 and 1, then your amplitude will decrease like this, shrink horizontally. It will look like a shrunken signal. If your value of a is greater than 1, then it will look like a stretched x of t. This is amplitude scaling. Now let us see the next operation, time reversal operation. Time reversal operation is, let us consider a continuous time signal x of t. If I mark this t with minus t, x of minus t, then this signal is time reversed version of this x of t. X of minus t is time reversed version of x of t. Let us see an example. Same example, let me take. U of t is equal to 1 for t greater than or equal to 0, 0 otherwise. We already know its graph t 0. This is u of t. It will look like this. If I plot u of minus t, how it will look? Let me substitute minus t instead of t throughout this equation. So u of minus t is equal to 1 for minus t greater than or equal to 0, 0 otherwise. So this minus will come this side, this minus will come this side. So this minus t greater than or equal to 0 will become t less than or equal to 0, because when we multiply minus on both sides, this symbol in between should be altered. If it is greater than or equal to, we should alter it like less than or equal to. So I multiplied minus 1 on both sides. Simultaneously I changed its symbol as less than or equal to. So now the condition is u of minus t is equal to 1 for t less than or equal to 0. So 0 for all values of t less than 0 will have value as 1 like this. up to infinity. This is 1. So let us compare the first u of t and u of minus t graph. How it is actually? It is just like a mirror image of this u of t on its origin. See, in this axis, in this y axis, in this x equal t equal to 0 axis, with respect to this axis, this whole graph is just altered like mirror image. This is how happens in time reversal operation. I hope you understood this topic. Let me go to next operation, that is time scaling operation. In time scaling operation, we will multiply a scalar into the time parameter, not with this function but with this time parameter like this. I have a signal x of t. If I multiply a scalar with this time parameter, then it is time scaled version of x of t. I can give an example with a discrete time signal, because already we discussed 2 examples in continuous time signal. So I feel like I didn't mention about discrete time signal. So let me take a discrete time signal. X of n is equal to minus 1, 2, 3, 4, 0, 1. And its graph, its index n equal to 0 is here. Now its graph is like this. X of n, this is n, this is 0. On n equal to 0 we have value as 3, and n equal to minus 1 it is 2. Sorry. More 2 here, so that it will be even more. Okay, 2, this is 2. And on n equal to minus 1 we have value as minus 1. This is minus 1. And in n equal to 1 we have value as 4. And n equal to 2 we have 0. N equal to 3 we have 1. Now let us consider x of 2n here. I scaled x of n, time scaled x of n with scaling factor 2. Now let me check its graph here. I will write it as a model first. X of 0 for n equal to 0. X of 0 is equal to x of equal to 3. Now x of 1 for n equal to 1, I am going to mark n as 1 now. So 2 into 1 I will get 2. X of 2 is equal to 0. Now I will take n as 2 now. So 2 into 2, n equal to 4. We don't have value for n equal to 4. So this is also 0. Now let us take negative part. Negative n's. Now n equal to minus 1. So it will become 2 into minus 1, minus 2, which is equal to minus 1. And n is equal to, now n equal to minus 2. So 2 into minus 2 is minus 4, so it is again 0. It will be 0 always. Now if I plot this graph x of 2n, I get value like this. For n equal to 0, I get 3. For n equal to 1, that is this value. That gave x of 2, which is 0, and n equal to 2 also 0. It continues to this way. This side, for n equal to minus 1, I got x of minus 2, that is minus 1, like this. And again x of, when n equal to minus 2, I got my x of minus 4, that is also 0. So when I see this signal, I feel like this x of n is actually shrunk with scaling factor 2. So we got this signal. So if we chose value greater than 1 for time scaling, your actual signal x of t or x of n will be shrunk this way. Okay, let us choose a value which is in between 0 and 1, so that we can see what happens for the actual signal. Let me give a new example for this. X of n equal to 3, 2, 1, 4, 1. Let this be n equal to 0. Now I want x of n by 2. Let me give values n equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. For n equal to 0, x of 0 by 2, x of 0, that is equal to 1. Here, this value 1. Now I am substituting n equal to 1 here. So x of 1 by 2, there is no value in between x of 0 and x of 1, so it is also 0. Now x of 2 by 2 is x of 1, that is equal to 2. Again x of 3 by 2, which is equal to 0. Next x of 4 by 2, that is x of 2, is equal to 3. Then x of 5 by 2 is equal to 0. X of 6 by 2, that is x of 3, is also 0. There is no value after this, so it is always 0 here. Now let negative value here. X of 2 is 1. Sorry for this. 1. And x of 3, all other values are same. Here I took this value, I am sorry. Also x of 1 is 4. I should have took this value, but I took this value. I am so sorry. Now let us consider negative values. So for n equal to minus 1, x of minus 1 by 2, that is 0, because we don't have values in between 0 and n equal to minus 1, so that is equal to 0. Now x of n equal to minus 2, so x of minus 2 by 2, which is equal to x of minus 1, that is 2. For n equal to minus 3, we get x of minus 3 by 2, that is equal to 0. For n equal to minus 4, x of minus 4 by 2, that is x of minus 2, which is equal to 3. N equal to minus 5, x of minus 5 by 2, that is equal to 0. It keeps on goes, because we don't have values after this, it will be like this. Let us see its graph now, so that we understand clearly how this time scaling works. Here it is 0, here it is n, here it is x of n by 2, it's not x of n, x of n by 2. Now let me plot. For n equal to 0 I got 1. Okay. Now n equal to 1 I got 0. N equal to 2 I got 4. This is 4. This is 1. And n equal to 3 I have 0. N equal to 4 I got x of 2, that is equal to 1, 3, 4. And n equal to 5, 0 again, and after all this we will get zeros followed by this. Now let us go for this negative side. For n equal to 1 we get x of minus 1 by 2, that is 0. For n is equal to minus 2 we get x of minus 1, that is 2, let this be 2. Okay. And for n equal to minus 3 we get x of minus 3 by 2, that is 0. Then for n equal to minus 4 we get x of minus 2, that is 3. Okay, it goes. If we see this signal looks like we stretched this signal this way. So why? I think this concept you understood very well. I will tell with this graph statement again. If we choose value greater than 1 for a, then that signal will be shrinked. If that is x of t, if I take x of 2t, then this x of 2t will look like I shrinked the x of t, like that we shrinked the x of t. If we chose this value greater than less than 1, like x of t by 2, then our graph, new graph x of t by 2 will look like we expanded the x of t this way. So we can expand or shrink the signal this way or this way using this time scaling operation. The scalar value can be anything, 3, 4, 5, 8, or 1 by 3, 1 by 4, 1 by 5, 1 by 8, anything according to our requirement. We can use any number like this. I hope you understood time scaling concept very well. Let us go to next topic, that is time shifting. In time shifting, if we have a signal like x of t, if we add or subtract, that means if we do additive operation with any scalar value with this time factor, it gives time shifted version. It can be x of t plus t naught or x of t minus t naught. This t naught is it can be any scalar value. For example, let us take our favorite unit step signal for this example. U of t is equal to 1 for t greater than or equal to 0, 0 otherwise. Let me take u of t plus 5 here. What happens? I will substitute, instead of t, I will substitute t plus 5 throughout this equation. So I get the same equation like this. 1 for t plus 5 greater than or equal to 0. So t greater than or equal to minus 5. 0 otherwise. If I choose u of t minus 5, then I will get 1 for t minus 5 greater than or equal to 0. That minus 5, if it goes to this side, it will become plus 5. So t greater than or equal to plus 5. 0 otherwise. Let's just plot both of this graph and see what is its actual difference. This is n, this is 0. I am plotting this graph first. U of t plus 5. It means t greater than or equal to minus 5. U of t plus 5 have value as 1. That is, this is minus 5. For t greater than or equal to this minus 5, it have value of u of t plus 5's value will be 1 throughout this value of n. Sorry, here I plotted it as n, it is t actually. Now again, let me plot this graph, u of t minus 5. This is n, this is 0, this is u of t minus 5. Its condition is like this here. It have value as 1 for all values of t greater than or equal to 5. That is, this is t greater than or, this is 5. So greater than or equal to 5, t greater than or equal to 5, for t greater than or equal to 5, u of t minus 5 will have value as 1. Actual u of t will be like this: 0, this is t, sorry again I made a mistake, this is t, u of t this is actual u of t, plus time shifted, plus 5 time shifted version of u of t is this u of t got shifted 5 units in this direction here for u of t plus 5. So if we plus any value with t, then your signal will get shifted to left side for that same number of units. If I plus 5, your signal will get shifted 5 units left side. If I minus like this, minus 5, if I do, then your signal will get shifted in right side for that same 5 units. This is time shifting operation. I hope you understood this topic. Let me show you this statement for your better understanding. If we do minus operation here, your signal will get shifted right side. If you do plus operation here, your signal will get shifted to left side. This is the actual meaning of time shifting operations. Followed by this, there are a lot of other hybrid operations are there, like signal will be given like x of t. They will ask you to plot x of 2t plus 1 by 3. Here we have few rules to follow, how to apply, which operation we should apply first. That let us discuss in next class with few examples. I will give you a simplest method to solve this. So I hope you all understood these 4 concepts clearly. If you have any queries, please write to this mail ID ece.youtubechannel@gmail.com, and this is my phone number. You feel free to ping me. Please watch this video, share to your friends, comment on it. Keep following us. Thank you. Please like, share, subscribe our channel.